Have you ever wanted to turn everyday photos into personalized art? Our project brings this vision to life. A tool that transforms your images into unique 2D avatars, blending your creativity with neural style transfer. With our system, users can upload a photo, choose from preset artistic styles like classic oil painting or modern cartoon, or even upload their own reference image to craft a completely custom look, and then choose a strength they want to adapt the style, like we just presented in this video. Just as painters master interplay of content and style to create visual experiences, our project uses deep neural networks inspired by biological vision to separate and recombine these elements algorithmically. Now, let's look into the algorithms the tool uses.
The core of our algorithm is a pre-trained deep convolution feed-forward neural network model. The constructor of this model consists of two parts. The first is the convolution neural network, which is used to extract the features, while the other is an optimization network which predicts the output and backpropagate gradients to update the real output. For the convolution fit neural network, each of the layers have slowed understanding and can extract different features like age, texture, objectives, and classes. By composing those layers or features together, this model can get a good understanding of the images. When you input images, those layers will extract the corresponding features and store them in the forms of feature matrices, which shows the correlation distribution between shape and colors. By analyzing those matrices, the model can compose them and generate the style of the image by a trick named gram matrix. Make a long story short, gram matrix is the style representation that computes the correlation between different features matrices, which help to analyze the style of the images. After we get the style of the images, we can then apply it to the content image and get the picture we want. And the style transfer will be done in the following process. The content image will push into the deep layer of the neural network and be extracted complex feature by the network. Then the style image will also push into the network, but in the shallow layers so as to extract some simple matrices, which can represent the style of the image. Finally, a white noise image is pushed into it to generate randomly predict content feature and the style features. In this way, we get the original images output and the generate images output. Now the two loss functions are applied to them. One measures the content loss while other measures style loss. After get all of this, we can apply backpropagation to reduce the overall loss function as much as possible.
Welcome to this demonstration of the image style transfer system. This project provides a user-friendly front-end interface to simulate this process of style transfer. The procedure is quite easy, consisting of uploading the original image, selecting the style image, selecting the output level, and the program will generate the target image, and we will give 4 examples about this. Let's go to our examples. For the first example, we use O1 image and the style 1. First, we drag and drop O1 into the left box. Once uploaded, the image and its file name will be displayed. Next, we select style 1. Finally, we choose the output level from 0 to 900. We take 300 and the 600 strings as examples. After one level is generated, the system will store the image so that it will not run again, which saves time and storage. For the second example, we use O2 image and style 1 to compare with the first example. First, we drag and drop O2 into the left box. Next, we select style 1. Finally, we choose the 300 and 600 strands as examples. And you can see that the same style is applied to a different image. For the third example, we use O1 image and a combined style of style 1 and style 2. First, we drag and drop O1 into the left box. Next, we select style 1 and style 2. We also choose 300 and 600 strands as examples, and you can see that the combined style is applied to the image O1. For the fourth example, we use O1 image and the combined style of style 1 and style 2. First, the original image remains the same. Next, we select a custom style by dragging an image into the style box. Finally, we select 300 as an example. And you can see that the custom style is applied to image O1. This front-end demo showcases a complete style transfer workflow. Thank you for watching.